Good morning, guys. Today we are doing our last lesson of Chapter 4, which is also the last lesson of Unit 2. So after this, we'll be moving on to our last unit. But today we're going to be talking about applying exponent laws. So last year in grade 9, you would have learned a bunch of the exponent laws. Today, we're just going to be learning how to apply all of those in situations that are a little more complicated than what you saw last year. And you'll also have to learn what we talked about or use what we learned about yesterday, which is how to get rid of negative exponents, because you'll be dealing with negative exponents this year when applying your exponent laws. So we'll just go over a quick reminder of what those exponent laws are, and then we'll do a couple of practice questions. Okay, so this is lesson 4.6, applying exponent laws. So just as a quick reminder, we'll go over what those exponent laws are. So if you have two powers with the same base, you can simplify that by just keeping the power. If those two powers are being multiplied, you add their exponents. So what that would look like is if, for instance, you had like x squared times x to the power of 5, you would multiply those together and get, you would add those together because we're multiplying and get x to the power of 7. Okay, so if you're multiplying the powers and the powers have the same base, you add their exponents. You can also have a power of a power, which looks like this. When you have two exponents separated by a bracket, you are going to multiply them together. So that would look like if, say, you had x squared to the power of 4, you would multiply those exponents together and get x to the power of 8. If you have an exponent outside of a bracket, it always gets applied to everything inside of the bracket. It could be that one of these is a number and one is a variable, or they could both be variables. So if you had something like 2x, for instance, all to the power of 3, then this 3 would get applied into our bracket to both the 2 and the x, and you'd end up with 2 to the power of 3 times x cubed. And anytime you have a power like this, where the base is a number, you want to actually simplify that. So 2 to the power of 3 is 8, and then we would keep our x cubed. For the next one, this is with division. So if we're dividing powers with the same base, we subtract their exponents and just keep the base. So for instance, if we had 2 to the power of 4 over 2 to the power of 3, that would simplify to 2 to the power of 1. Because I'm subtracting the 4 and the 3 to get a 1. And then again, anytime we have a power and the base is a number, you want to actually solve that. So 2 to the power of 1 is just 2. And then lastly, again, anytime you have an exponent outside of a bracket, it gets applied to everything inside the bracket. So for instance, if I had x over y all to the power of 3, I could simplify that as x cubed over y cubed. Okay, just a couple rules here at the bottom to remember when you're solving these problems. You can only simplify from multiple bases to a single base if the bases are the same. Okay, if the bases are different, they have to stay different. So I could not subtract these two exponents, even though I'm dividing, because my bases are different. Okay, so in the above example, my bases were the same. They were both 2. That's why I could subtract their exponents. The bases are different, you cannot. So we can only simplify if bases are the same. Whole numbers will divide and multiply like normal. Okay. They will also solve like normal. So you can just plug the base and the exponent into the calculator to solve. And then lastly, and this is the part that'll be really different from last year, exponents can only end up positive. So if you do your exponent laws and you end up with a negative exponent, you're going to have to do what we did yesterday in order to get rid of that negative exponent, which is to take the reciprocal of your base. Okay? Okay, so we're going to go over 3 examples, each one more complicated than the one before it. So we'll start off with a fairly simple one. We have 10 times a to the power of 4 times b to the power of 3 divided by 5 times a to the power of negative 2 times b to the power of 5. So we're going to start by using our exponent rules to simplify our like terms or like bases. So our whole numbers are going to be able to simplify with each other. Our a's can simplify with each other, and our b's can simplify with each other. Our whole numbers just divide like normal. So 10 divided by 5 is 2. Then for our a's, because they're dividing, we subtract their exponent. So we're just going to keep the base of a and then subtract the exponent. So 4 take away negative 2 is 6. And then same thing with our b values. We keep the base, and because we are dividing, we subtract the exponents. So 3 minus 5 is negative 2. Now, all of this is simplified, but as we talked about for one of our rules, we are not allowed to keep a negative exponent. So we have to take our b, which is the base of this power, b to the power of negative 2, and we have to take the reciprocal of it. Now remember, anything can be over an imaginary 1 if it's not already a fraction. So when I take the reciprocal of that, my 2 times a to the power of 6 isn't going to change, but my b is going to get flipped upside down. So now it's 1 over b, and that makes my exponent positive. And then the last step is to just squish this all together and simplify. So right now I have 2 times a to the power of 6 times 1. And the easiest way to write that is just 2 times a to the power of 6, because multiplying anything by 1 doesn't change what it is. And then if you want to put all of these over 1, it might make it easier to see what's happening here. I have 1 times b squared, which is b squared. Okay, so when I took the reciprocal of my b power, it got flipped to the bottom. That's why it ends up on the bottom of this fraction here. Okay, so step 1 is to just simplify using our exponent rules. Which is what we did here, just our normal dividing and then subtracting our exponents when we're dividing. Step 2 is take the reciprocal to get rid of any negative exponents. And then step 3 is squish it all together. And we do that by just multiplying. Okay, the stuff that was on top stays on top, the stuff that was on bottom stays on bottom. Squish it together. And that's it. Okay, let's try one that is a little more complicated. Okay, so for this one, we have now included some brackets that we're going to have to deal with. In this case, because we have operations happening on the top and the bottom here, we have to simplify the top and bottom separately using our exponent rules before we can do the division that we had done last time. So we're going to use two exponent rules at the same time. The first is that when you have an exponent outside the bracket like this, it gets applied to everything in the bracket. So it's this 3 that I have outside the bracket here is going to get applied to the 2, to the x, and to the y squared. Okay. Most common mistake here is to forget to give it to the 2 and to only give it to the 2 variables. Remember, the 2 is its own base. So the 2 gets a 3, the x gets a 3, and the y squared gets a 3. And then on the bottom, we're going to use multiplication to simplify. Okay? So what this ends up looking like, 2 to the power of 3 is 8. X, when we apply this 3 in, anytime there is no number as an exponent for a variable, there's really an imaginary 1 there. So this is 3 times 1, which is 3, so we end up with x to the power of 3. And then y squared, when I apply this 3 in, again, I'm multiplying it in, so I end up with 3 times 2, y to the power of 6. Okay, so that is how I have simplified the top, by multiplying that 3 in. Okay, now keep in mind, it gets multiplied in to the variables here, to my x to the power of 1 and y squared. It just acts like normal when I apply it to the 2. So that's how I've ended up with the 8 here. 2 to the power of 3 is 8. Now we're going to deal with the bottom. I have this 2 here. There's no other whole number on the bottom, so I'm just going to keep that as a 2. And then I have these 2 x's that are going to go together, and these 2 y's that can be simplified together. Now, because these are both in brackets, I am multiplying them together. When I multiply powers with the same base, I add their exponents. So x to the power of 6 times x squared, I'm going to keep my x, and then add 6 plus 2 leaves me with 8. And I'll do the same thing with my y's. Remember, if I have a variable like this and there's no exponent, there is an imaginary 1 there. So don't forget about your imaginary 1. So then y, if we do -3 plus 1, that gives us -2. Okay, so don't forget this imaginary 1. If you forget it, you'll have a -3 here instead. Now we use the same steps we used in the last question, so our whole numbers can simplify together, our x's and our y's. Our whole numbers just divide like normal, so 8 divided by 2 is 4. X to the power of 3 minus x to the power of 8, we are going to keep our base and subtract our exponents. So 3 minus 8 is -5. And then again, y to the power of 6 and y to the power of -2. Because I'm dividing, I'm going to keep my base and then subtract the exponents. So 6 take away -2 is 8. And then my last step is to get rid of this -5 exponent here. So my 4 isn't going to change. My x has to get flipped upside down. It's really over an imaginary 1. So when I flip it, it is now 1 over x to the power of 5. I'm just going to put it in brackets. And then my y already has a positive exponent, so it's not going to change. And then my last step is to squish it all together. So 4 times 1 times y to the power of 8 is just 4y to the power of 8. And my x to the power of 5 is on the bottom. You want to put these all over 1 to help you kind of see what's going on. You can. So 1 times x to the power of 5 times 1 is just x to the power of 5. So that's your final answer. Okay, so these are the steps that we took. So first we simplified the top and the bottom separately using our exponent laws. So multiplying in that external exponent and then adding our exponents when multiplying like bases. Again, don't forget that imaginary 1. So anytime you see a variable that does not have an exponent, write in a little imaginary 1 for it. It'll make using your exponent laws much easier. Our second step was to continue simplifying using our exponent laws, and now we were able to simplify dividing. And when we divide, we subtract our exponents. Then our third step was to take the reciprocal of anything that had a negative exponent in order to get rid of that negative exponent. And then our last step was to just squish it all together. Anything that was on the top stays on the top. Anything that was on the bottom stays on the bottom. Okay. We're going to try one more example, this time involving some fractional exponents. Okay, so this looks very similar to the question we just did. The only difference is that we now have some fractional exponents in there. But we're still going to start by solving the top and bottom separately if possible. There's actually nothing to solve on the bottom right now, but the top does have this external exponent. So that is going to get applied in to everything in the bracket. So we're going to start by doing 4 to the power of 1/2. Then we have x squared times 1/2. So I'm just going to go over to the side over here for a second and figure out what 2 times 1/2 is. Now the reason I'm doing it off to the side is you could just plug this into your calculator and solve it, but if it gives you a decimal, you have to keep it as a fraction. So it's good to just always get in the habit of solving it by hand. So when I'm multiplying fractions, I just make sure that they are both written as a fraction. So I will write my 2 as 2 over 1, and then we just multiply straight across the top and straight across the bottom. So 2 times 1 is 2, 1 times 2 is 2. And then I can simplify that. 2 over 2 is 1. So x to the power of 1. Now, normally we don't bother writing in 1 as an exponent, but this time we will because we want all of our variables to have an exponent. If they don't have an exponent, we write in an imaginary 1 anyway. And then for our y, we have to do 3/4 times 1/2. So again, I'm going to go off to the side somewhere and do 3 over 4 times 1 over 2. I multiply straight across the top and straight across the bottom and get 3 over 8. And that cannot be simplified anymore. So we'll just keep it as 8 to the power of 3 over 8. Sorry, y to the power of 3 over 8. And then I haven't done anything to the bottom. It's just going to stay the same for now. Next step is to figure out what 4 to the power of 1/2 is. And if you write 4 to the power of 1/2 and you use the rules that we learned 2 days ago, it would be to turn this into a radical. So I'm going to keep my base as my big number. The denominator becomes the index. So this is a square root. And the numerator becomes the power. So really, this is just the square root of 4, which is 2. So that leaves me with 2x to the power of 1, y to the power of 3/8 over 2x to the power of 4, y to the power of 5/8. Now I can just simplify my whole numbers, my x's and my y's, all separately. 2 divided by 2 is 1. X to the power of 1 times x to the power, or sorry, divided by x to the power of 4. When we're dividing, we subtract our exponents. So that leaves me with x to the power of -3. And then my y, again, when I'm dividing, I'm going to keep my base and then subtract 3/8 minus 5/8. So 3/8 minus 5/8. Again, I'm going to go do my fractions off to the side. When you're subtracting, you do need a common denominator, but I already have one. And then I subtract across the top and the bottom stays the same. So 3 take away 5 is going to be -2. So I have y to the power of -2/8. Then, of course, I need to get rid of my negative exponents. So my 1 is going to stay where it is, but my x is going to get flipped upside down. So it becomes 1 over x. That turns the exponent of -3 into a 3. My y also gets flipped upside down. It becomes 1 over y, and my -2/8 becomes +2/8. I then want to make sure that any fractions are in lowest terms. So 2/8 is not in lowest terms. I can simplify that even further. So 2/8 can be written as 1/4. I just divide the top and bottom by 2. So I have 1 times 1 over x cubed times 1 over y to a quarter. And then my last step is squish it all together. 1 times 1 times 1 is 1. And then I'm left with my x cubed and y to the power of a quarter on the bottom. So that is my final answer. Okay, so these were the steps that we followed. We started by solving the top and the bottom separately. In this case, there was nothing to solve on the bottom. We just had to solve the top by multiplying in that fractional exponent. Then solve any whole number fractional exponents by converting into a radical. This was the one step that was new compared to the last problem that we did. So this whole number 4 had a fractional exponent 1/2. So we solved that right here by turning that fractional exponent into a radical and solving like that. Again, sometimes you will just be able to plug this into your calculator and solve, but sometimes you'll get a decimal doing it that way, and so that's why we do it this way instead. Then we simplified here using our exponent laws. We took the reciprocal of anything with a negative exponent to get rid of the negative, and then we squished it all together. Okay? Don't forget, everything should always be in lowest terms if you have a fraction. And that is it. We are going to spend the next 2 days practicing this.